Alright, today we're going to talk about another kind of transformation of a shape. Let's look at this triangle here. We got triangle ABC, and we are thinking about reflecting it over line N. Okay, if you remember from our last video, when we reflect, our points are equidistant. So if I have B here, then this is 1, 2, 3 away from my line of reflection. So I know that B, what we are going to call prime, this is new notation for you guys, B prime, which is like a little apostrophe. That means it's the corresponding point after it's been reflected or transformed. So after it's been reflected, now we call this B prime. All right, we're going to do the same thing here with A. A is 9 across. So we know that this is also going to be 9 across. 9. If you did not want to do that, count that all out and call that A prime. You could also count from B, how far apart are B and A, because remember when we reflect a shape, it's congruent. Emma mentioned that congruent means that it's the same size, has the same angles, same length of sides. So notice B here, right, is up 3 over 1, 2, 3, 4, 5, 6. So you could also do the same thing here. From B, I go up 3, and then I'm also over 6. So that also works if you don't want to count the full way across. Okay, last step here is to get C. Again, I don't want to count how far C is, so I'm just going to count how far away B is from C. B is 1, 2, 8 away. So I know that C prime will also be 8 away from B prime. 1, 2, 8. And that is 2 off from A prime. And C is also 2 off from A prime. And then we can draw our triangle. All right, so this is our first reflection. We got A prime, B prime, C prime. What if we reflect it over line P? So same idea. We're going to reflect. C prime is 3 away. Now we're going to call this C double prime because this is me doing something with the shape a second time. So I flipped it once and now I'm going to flip it again. So C double prime. C and A are up 3 over 2 from each other. So I'm going to go up 3, 1, 2, 3, and over 2. And that's going to be A double prime. And then B and C, like we mentioned, was up 3 and 6 apart, I think. So we're going to go 6 apart. 1, 2, 5, 6, and then down 3. 1, 2, 3, double prime. All right, let's take a look at all 3 of our things here. So we got our original or our pre-image, and then we flipped it, and we got our image, and then we flipped it again, and we have our second image here. There's a nice relationship going on here between this very first one, our original, our pre-image, and then this image over here. It's almost as if I just took this and I slid it across. Bloop. And that is what translation is. Translation means that we take a shape and we just slide it. How far did I slide it though? So if I want to give someone instructions, I'd have to tell them how far I slid this. So this is 1, 2, 3, 28. All right, so we took our B value and we slid it across 28 units. So a way we could write this is instead of x comma y, we transformed it by shifting our x 28 units over, right? We shifted B and we went across horizontally in the x direction 28 units. So we're going to rewrite this as x plus 28. And similarly, we can give directions for the y coordinates. How far vertically did we shift? And I did not move, like my B, right, is still on the same line as my original B, my B double prime and my B prime. Anyway, they're all on the same line. So I did not shift up or down any. So I could just leave this as y plus 0, or I could also just call it y. So this is some notation you'll also see in your assignment. This just gives you directions for how to get from your original or your pre-image to your new image. And so with translation, you'll always be adding certain amounts to your x value or your y value. You could also be subtracting. So if you're shifting left, that would be minus. If I want to shift 5 over, then that would be like minus 5. If I want to shift up, then that would be like y plus 2 if I want to go up 2 units. Or if I want to shift down 3, I would do y minus 3. So you can kind of see the different combinations. But this is how we write the rule for translating shapes.
All right, so now we are going to practice translating using this notation, this rule, which tells us how we're going to change our x, how far over we're going to move x, and how far up or down we're going to move y from our pre-image to get the new resulting image. So if we look at this rule, it says it's taking our original xy coordinates, okay, and it's moving x plus 3, which means 3 in the positive direction, and y down 4, negative 4. And so we are going to take each of these points, A, B, C, and D, and we're going to move it over 3 in our x direction and down 4 in our y. So if we look at A, we need to go over positive 3. So if we're right here, we're going to go 1, 2, 3, and then from this point, we're going to go down 4. 1, 2, 3, 4. And this right here will be our new point, and we'll call this A prime, which, as Tiana explained in the last example, is just the point that corresponds to A from our pre-image to our image. So now we're going to do that with the rest of these 3 points. 4, 1, 2, 3. Doesn't matter if you go down first, then over. This is D prime. Okay, and then also we can look at the distance that B is from C, and we can do it that way if we don't want to go down 4 over 3 every time. B and C are 4 apart from each other, then I can just make sure I go 2, 3, 4. And this point here will be B prime. Okay, so now we have our new shape, our image. We translated it over 3 and down 4. All right, so another way that we can think about translating using this rule is if we just look at the points. We have each point labeled from our pre-image right here, so that this point right here, negative 8, 2, is point A, negative 7, 4 is point B, negative 3, 4 is point C, and negative 4, 2 is point D. So this tells us where A, B, C, and D are in our pre-image. If we didn't want to have to count all the little squares to get our new image, we can use this rule with the points. So this rule tells us that we're going to change our x by adding 3 and change our y by subtracting 4. We're going to take this point here, negative 8, 2, and we are going to add 3 to our x, and we are going to subtract 4 from our y. So negative 8 plus 3 gives me negative 5, and 2 minus 4 gives me negative 2. And then if we come back over here to a prime, we can see that's exactly where this point is. It is over the negative 5 and down to negative 2. So this point right here is negative 5, negative 2. So we could do that with each of these points to figure out where they would land on the grid.
We're going to talk about another way that you can transform a shape. So far we've talked about reflection. You can take a shape and you can reflect it. We talked about translation, where you can slide a shape up and down, left and right. And now we're going to talk about another type called rotation. You guys are probably familiar with rotation. In everyday talk, we talk about just turning, right? If we're turning. And so if I have a shape here, we're going to talk about rotating it different ways. So we're going to use vocab words and stuff to describe that. But how much are we turning it by? We'll need to learn some new vocabulary to kind of help us understand how far are we turning it, which way are we turning it, etc. So let's first talk about direction. There are 2 ways that you can turn or rotate a shape. You can rotate it clockwise in the direction of a clock, right? Think about a clock clockwise, okay? Or you could also rotate the other way, right? Instead of turning towards the right, you could also turn towards the left or go counterclockwise. So you can go clockwise or counterclockwise, either way. So those are the 2 ways we can describe rotating shape. All right, now that we know about direction, let's talk about degrees, like how far are you rotating it before you stop? Because we're working with coordinate grids, it's really nice to split up our rotations into the sections of the quadrant. So when I start up here, I'm in the first quadrant and I can rotate 90 degrees, which is 1/4 of the way. So that would be roughly there. And then if I go another 90 degrees, that would put me here, which is 180 degrees. That's turning it halfway, right? Here, turning my paper halfway. Okay, and then I can also go 270 degrees. That would put us right here. And then I could go all the way back around, and that would be 360. So if any of you guys snowboard or skateboard, 360, it's a full spin, right? Full turn. Yep, and you land right back where you start. Awesome. Notice that if I go 90 degrees clockwise, that is the same as going 270 degrees counterclockwise. Notice that going 180 degrees clockwise is the same as going 180 degrees counterclockwise. That will land you in the same spot. Transitioning back to our tracing paper here. If, let's say, we want to rotate this shape 90 degrees clockwise. Sometimes we use that as CW. Sometimes you'll see an arrow going in the direction I want you to go. So 90 degrees clockwise. And one thing that helps is to draw like a little arrow to know which way was up originally. And I know when I turn 90 degrees clockwise, my arrow is actually now going to be facing this way. So you can use tracing paper to try to copy it, and then when you turn it, you can like line it up with the center rotation again. If that is a little bit tricky, you can also not worry about tracing paper, and you can just count how far up and over you are. So for example here, I went up 2, over 2, and so that was how I was facing this way, this orientation. So if I flip myself, 90 degrees, and I go up 2, and I went right 2, so I'm also going to go right 2 with this direction, and that's going to be this new point. Okay, we can repeat that again. I go up 2 and over 5 to get to this end point, so I'm going to go up 2, over 5, and that will put me right here. Okay, my next coordinate is at 5, 3, so that means I went right 5, up 3, and so if I rotate myself, I go right 5, up 3. I could also just go up 1 from where I was originally, and then you can just kind of draw it from there. You can continue that all the way around if you want to, or if you have enough to fill in the shape, you totally can. On Derivita, they'll let you rotate and angle the points how you want, but that might be a good way to get started on which point goes where.
All right, so now we're gonna practice rotating this shape right here, 180 degrees counterclockwise. So the counterclockwise, sometimes you write CCW or draw the arrow. We wanna go counterclockwise. And if we remember with 180, it's a halfway turn over here. So when they say rotate at 180 counterclockwise, really, we could do it clockwise too, and we'd end up in the same spot, but we're gonna do it counterclockwise. So if I have my center of rotation right here, I'm gonna draw an arrow because that is where I was originally facing, okay? And if I wanted to rotate it 90 degrees, I would end up going this way and my arrow would be pointing to the left, but I want my arrow to be pointing down because that is a 180 degree turn. If I look at the distance from the center here, I can look at this point right here. I know that I have to go from the center up to over to, so I'm gonna come down this point and I'm gonna go down to over to get my point here. Over at this point, I had to go from the center, I went up 2 and then over 5. So from the center, I'm going to go down 2 to the left 5. And this will be my new point right here. Okay, and then I'll do it again for maybe this point up here. So from the center, I had to go up 5 over 2. So on this point, I'm going to go down 5 over -2. And I'll start connecting my shape. And I'll maybe do one more point, this point right here. So from the center of rotation, I had to go up 3 over 4 to get to this point. So I'm going to go down 3 over 4 right here. And then I can finish drawing my shape. So we can see that if we start here at our original shape, this is rotated 180 degrees counterclockwise or 180 degrees